In this video, we'll be going over problem 6 in the January 2020 CXC Math exam. In part A, we're given a diagram of a rectangle with circles inside. It says that the radius of each circle inside the rectangle WXYZ is 7 centimeters. The first part asks us to show that the area of the rectangle is 2,352 centimeters squared. Remember that the area of a rectangle is the product of its length and its width. So we need to first find the length and the width of this rectangle. The length of this rectangle is the side WZ. From our diagram, we can see that this length is the same as 3 circles stacked up. This means that the length of WZ is equal to 3 times the diameters of the circles. Now remember that the diameter of a circle is twice its radius, so we can rewrite this as 3 times 2 times the radius. Our problem tells us that the radius of each circle is 7 centimeters. So I plug that in for the radius. I get 3 times 2 times 7 centimeters, which gives me 42 centimeters. The width of this rectangle is the side ZY. We can see that this is the same as 4 circles placed side by side. So the width of our rectangle is equal to 4 times the diameter of the circles. And again, the diameter is 2 times the radius, so we can write this as 4 times 2 times the radius. And plugging in 7 centimeters for the radius, we have 4 times 2 times 7 centimeters, which gives us 56 centimeters. Finally, the area of a rectangle is equal to the length times the width, which in this case is 42 centimeters times 56 centimeters, which gives us 2,352 centimeters squared. In part 2, we are asked to calculate the area of the shaded region. From our diagram, we can see that the shaded region is what's within the rectangle but outside of each of those circles. So the area of the shaded region is the area of the rectangle minus the area of the 12 circles within. This can be expressed as the area of the rectangle minus 12 times the area of one circle, since all of the circles here are identical. From our first part, we know that the area of the rectangle is 2,352 centimeters squared. I'm going to take this and subtract 12 times the area of one circle. Remember that the area of a circle is pi times the radius squared. So plugging in 7 centimeters for the radius, we have 2,352 minus 12 times pi times 7 squared. In this problem, we're asked to assume that pi is 22 divided by 7. So I can write this as 2,352 minus 12 times 22 over 7 times 7 squared. Entering in 12 times 22 over 7 times 7 squared into our calculator, we get 1,848. So the area of our shaded region is 2,352 minus 1,848, which gives us 504, and the units that we need here is centimeters squared. So that's our answer to this problem. In part B, we are given the diagram of a triangle MNP. We are told that the angle MPN is 52 degrees, and the angle PMN is also 52 degrees. And we're also told that the side MN is 12.5 centimeters. In part 1, we're asked to identify the type of triangle that we have here. Since the angles MPN and the angle PMN are the same, they're both 52 degrees, I know that the side PN has to also be 12.5 centimeters. Since this triangle has two sides that have the same length, we know that this is an isosceles triangle. In part 2, we're asked to find the value of the angle PNM. For any triangle, we know that the three interior angles have to add up to 180 degrees. So this tells me that the angle PNM plus the angle MPN plus the angle PMN has to equal 180 degrees. In our problem, we're told that the angles MPN and PMN are both 52 degrees, so I can substitute that in. So this gives me the equation, the angle of PNM plus 52 degrees plus 52 degrees is equal to 180 degrees. So solving for the angle PNM, I get that this is 180 degrees minus 52 degrees minus 52 degrees, which gives me 76 degrees. In part 3, we're asked to calculate the area of the triangle MNP. To calculate the area, I'm going to draw a line that's perpendicular to PM from the vertex PNM. Since we have an isosceles triangle, I know that this line splits our triangle into two identical pieces. I'm going to label the point where my line intersects PM as X. Then I'm going to label the length from X to M as B and the length from X to N as H. We'll start by finding the area of the triangle XNM. In general, the area of a triangle is 1/2 times its base times its height. So the area of the triangle XMN is 1/2 times B times H. So we'll need to start by finding out the lengths of B and H. To do that, we'll need to use some trigonometry. Let's label the angle PMN as the Greek letter alpha. Now, for any right triangle, we know that the sine of an angle, in this case the sine of alpha, is equal to the opposite side divided by the hypotenuse. In our case, the side opposite to alpha would be h, and our hypotenuse of this triangle is 12.5 centimeters. So I can solve for h by multiplying both sides of this equation by 12.5. We get that h is equal to 12.5 times the sine of the angle alpha. Plugging in 52 degrees for alpha, we know that h is equal to 12.5 times sine of 52 degrees. We also know that for right triangles, the cosine of an angle, say alpha, is equal to the adjacent side divided by the hypotenuse. In our case, the adjacent side to the angle alpha is b, and the hypotenuse is 12.5 centimeters. Now, if I multiply both sides of this equation by 12.5, I can solve for b, so we get that b is equal to 12.5 times cosine of alpha, and plugging in 52 degrees for alpha, we have 12.5 times cosine of 52 degrees. So I know that the area of the triangle XMN is equal to 1/2 times B times H, which is 1/2 times 12.5 times cosine of 52 degrees times 12.5 times sine of 52 degrees, which we can rewrite as 1/2 times 12.5 squared times cosine of 52 degrees times sine of 52 degrees. What we're really interested in is the area of triangle MNP. Now, in the beginning, we divided our triangle into two identical pieces. So the area of triangle MNP is 2 times the area of triangle XMN. So that's 2 times 1/2 times 12.5 squared times cosine of 52 degrees times sine of 52 degrees. this simplifies to just 12.5 squared times cosine of 52 degrees times sine of 52 degrees. Now, if you want, you can enter this expression into your calculator, and you get that the area of your triangle is approximately 75.8, and the units here are centimeters squared. So that's your final answer.